Hey everybody, Mr. Fortin here. We got construction number 11. Yeah, we've had kind of a lot of construction so far, but this is a big one. Construction number 11, counting them up, we've done 10 already. Wow, that's a lot. Anyways, parallel line through a point outside of a line here. So I have a given diagram, and this is something that we can defend because we know if we have a line through any point that's not on that line, there's exactly one parallel. Okay, that's a theorem from chapter 4 earlier in the year. Okay, so here we're actually going to construct that exactly one parallel that exists. We're going to figure out where that's going to be on paper, at least using our geometric properties. Okay, so just to remind you guys, whenever you're doing construction, your objectives are to use geometric properties to find whatever it is you're trying to construct. Okay, so I'm going to use geometric properties here to construct a line, okay, parallel to line L that passes through point P. Okay, now point P could have been kind of anywhere, right? So that means it could be way far away. So I can't just drag my compass, for instance, to get parallel lines. I need to figure out another way where, say, P is super far away. How can I construct something else near P that would be here? That would be congruent to something that's down here now. You'll see it in a second. Okay. So second objective here is to show markings that clearly support the geometric construction. Okay. So as we saw in class today, this is the classic construction of parallel lines. Is going to rely upon the fact that the stuff we studied last semester was that parallel lines get formed when you have a transversal that with the two lines that hit the transversal, you have congruent corresponding angles. That's the way that I usually do it. You can also do it too if you can get a transversal and you can find congruent alternate interior angles. That would be enough to introduce two parallel lines. But anyways, I'm going to do the corresponding angles approach. So check it out here. The way we do it, step one, draw a transversal. Okay, so I'm just going to draw. It can be anywhere here. It could be like this. Okay, it can be like this. It doesn't really matter. I'm just going to draw any old random transversal here, and it's not a transversal yet because I don't have two lines that this line is transversing, right? It's going across here. So I have this line here, and then my parallel line is going to be somewhere over here, right? Going to be somewhere over here. If I can get it so that this transversal is going to hit my parallel line in this one. If I can get my parallel line where corresponding angles are congruent, then that's going to be enough to show me that whatever this ray is right here would have to be parallel to this line, okay? So what I'm going to do in this construction is I'm going to copy this angle, okay? So this is construction number 4, copying an angle. So I already justified. Step 1 is draw a transversal from the line through the point. Step 2 is construction number 4, copy angle. Copy this angle that gets formed at the intersection of the transversal and line L, and copy that up here where you expect your congruent corresponding angles would have to be if you had parallel lines, right? This angle that's going to be up here would have to be congruent to that angle down there if the lines were actually parallel, okay? So here, remember, copying angles, I do that the SSF method. These lengths are the same as this length right here. It's the same as all these other lengths here. I just need to figure out where to draw the ray so that I get an SSS correspondence, okay? So the second thing to copy an angle, I've looked at it several times, but people get lost here. I set my center here. So these two lengths are the same. I'm going to stay away from that. Sorry, these two lengths are the same. It's the same as this. I'm going to stay away from that. I care about this third length here to copy an angle. So now I'm going to place my center on the intersection that I created in the first step of copying an angle, and then down here. I oftentimes want to see this, guys. I want to see you actually measuring that up on the original angle down here. Because what am I going to do? I'm just going to come back up here, and I'm going to measure off that same length. Okay, so what do I know about this here? I know that that length right here is the same as this length down here. This length down here is the same as this length right here. And what do I know about that length? Well, this arc here, my radius didn't change. It's the same as this length down here. So you have some 3 congruent kind of invisible triangles down there, and you know that corresponding angles in triangles are congruent. So if I draw in, finish this copy angle, okay, and I draw it this way, I'll do it in red just to contrast a little bit with the blue that we have up there. If I complete this angle here, I know that that line has to be parallel to that line. Why? I copied angles. So I have congruent corresponding angles. They're both in the top right position here as the transversal hits those two lines, okay? So if I just extend it using my straight edge, okay, then I get a little bit more, it looks more like a line, looks less like a ring. And that's maybe what you had kind of envisioned here, okay? So I can prove, I can defend that line M would have to be parallel to line L because corresponding angles are congruent because I copied them after all here. Construction number 11 done. Thanks for watching, guys. Let me know if you have any questions.